All right, today we're going to unlock two of Python's most powerful, I'd say, secret features, decorators and generators. Now, these aren't just some fancy party tricks. Nope. These are professional-grade tools that are going to help you write way cleaner and much more efficient code. So, let's dive right in.
So let me ask you something. Do you ever find yourself just copying and pasting the same few lines of code over and over again into multiple functions? Or maybe you've tried to process some massive data file, only to have your computer just grind to a halt. If any of that sounds familiar, then you are in exactly the right place. We're about to make your code work a whole lot smarter, not harder.
Let's kick things off with our first superpower, decorators. These are such an elegant way to add functionality to functions you've already written, and they help us follow a really important principle in the world of software development.
And that principle is dry. Don't repeat yourself. You know, every single time you copy and paste code, you're just creating a headache for your future self. Because if you need to make a change later, well, now you've got to hunt down and update every single copy. It's a total mess and an open invitation for bugs to creep in.
And here we go. This is a perfect example of what I'm talking about. Just look at these two functions. Yeah, the core task is different. One does task A, the other does task B, but that timing logic, starting the clock, stopping it, printing how long it took, it's identical. It's copy-pasted. This is a classic violation of the DRI principle. There's got to be a better way, right?
And there is. It's called a decorator. Think of it like this. A decorator is basically a function that wraps itself around another function. It lets you inject code to run before and after the original function does its thing, all without ever touching the original source code. It's this super clean, reusable way to add behaviors like logging or timing, or even checking user permissions.
I love this analogy. It's perfect. Your function, that's the valuable gift inside the box. The decorator, that's the fancy wrapping paper and the bow on top. The gift itself is completely unchanged, but its whole presentation is way better. It's just a great way to think about how decorators add value without being invasive.
So how does this magic actually work? Well, it's actually way simpler than you might think. All you do is you put the decorator's name with an @ symbol in front of it, right on the line above your function definition. That's it. Python sees that and does the rest of the work for you, automatically passing your function through the decorator and swapping it out with the new, supercharged version. Okay, that seems almost too easy, doesn't it? Well, like with a lot of powerful tools, there's a little catch, a common pitfall that trips up a lot of people when they're starting out. And it all has to do with what happens to your original function's identity. Okay, so check this out. If we look at a normal function, before we've done anything to it, Python knows everything. It knows its name, it knows the little doc string we wrote, it knows its arguments. And this introspection, this ability to look inside our code is so useful for debugging. But look what happens after we slap on a simple decorator. All that original information, it's gone. Our function now thinks it's the generic wrapper function from inside our decorator. The original name, the helpful docstring, it's all vanished, which, trust me, makes debugging a total nightmare.
So what's the fix? How do the pros handle this? Thankfully, Python gives us a beautiful built-in solution that professionals use every single time. It's a special decorator that lives in the functools module, and it's called wraps.
That's right, it's a decorator for your decorator. You apply @wraps to that inner wrapper function, and it very cleverly copies all that important info, the name, the docstring, all of it, from your original function over to the new one. This little step is what separates a quick and dirty decorator from a truly professional, robust one. It's absolutely crucial.
Okay, that's one superpower down. Now, let's switch gears completely and talk about our second one, generators. We're going to tackle a totally different kind of problem now. How do you handle absolutely enormous amounts of data without, blowing up your computer? Just imagine, you have to process a log file or maybe a database query that has a billion, with a B, rows. If you try to read all of that into a normal Python list in memory, your computer is basically going to scream and then probably crash. Most computers just don't have enough RAM to handle that. So the solution is a generator. See, unlike a regular function that does all its work and then returns one giant result at the end, a generator is special. It's a function that can literally hit pause on itself, hand you a value using the yield keyword, and then wait for you to come back and ask for the next one. And this right here, this is the absolute heart of what makes generators so special. It's the difference between return and yield. A function with return builds that whole billion item list at once. A function with yield becomes a generator.
It gives you one value, pauses, remembers exactly where it left off, and just patiently waits for you to say, okay, give me the next one.
This whole concept is called lazy evaluation. And I mean lazy in the best possible way. It's smart lazy, not lazy. The generator doesn't waste any time or any memory calculating values you might not even end up needing. It only does the work to produce the very next item, right at the moment you ask for it. It's incredibly efficient.
So, what's in it for you? Well, the benefits are just massive. You get unbelievable memory efficiency, which is a total game changer for big data. Your performance is often way better because you're not sitting around waiting for a huge list to be built. And honestly, the code is often just cleaner and easier to read than building a whole custom iterator class from scratch.
All right, so we've looked at these two amazing tools. But just to make sure it's all crystal clear, let's put them side by side for a final showdown.
Yeah, this table really nails it, doesn't it? A decorator, with its at syntax, takes a function that already exists and modifies its behavior. It's the gift wrapper. A generator, with its yield keyword, produces a sequence of values from scratch. It's the assembly line. They solve fundamentally different but equally important problems.
So there you have it. Two incredibly powerful new tools for your Python toolkit. Now let's talk about when you should actually pull them out of the box.
So here's your mission, your main takeaway from all this. The very next time you catch yourself copying and pasting some logging or timing code, I want you to stop and think, wait a minute, this is a job for a decorator. And the next time you're looking at a huge file or a data stream that's too big for memory, think, aha, this is a job for a generator. And that really brings us to our final thought. You know, anyone can write code that just works. But what's the difference between code that works and code that's truly masterful? It's about writing code that's elegant, that's efficient, that's professional. And mastering tools like decorators and generators, well, that's a giant step on that journey. It's about knowing you have the right tool for the job and using the full power of the language to write code that isn't just correct, but is masterfully crafted.